Hello and thank you for joining me today. Today we're going to talk about how you can secure your Azure Arc enabled data services to run SQL managed instances and databases. Security of data assets is obviously very important for many organizations and enterprises out there, and many of our customers are using today SQL Server or our Azure data services in the cloud, but also with Azure Arc enabled data services. And now with the business critical tier of Azure Arc enabled data services, customers want to know how they can secure their mission critical workloads running on premises or other cloud providers. So I'm excited to have Dhananjay with me today. Dhananjay is a principal program manager in the Arc-enabled data services team to talk about the security features we integrated. How are you, Dhananjay?
Oh, wonderful, Thomas. Thanks a lot for the brief intro. My colleagues call me DJ Data, so if that makes it easier, I'm excited to talk to you about the security features that we have enabled in our platform for you to run your mission critical data.
No, it's absolutely awesome. And again, I'm super excited to have you here again to talk about this. So we're here today to talk about the security of Azure Arc enabled data service SQL managed instance, right?
Yes. Security is very important to Microsoft and our customers. So before they decide to deploy any of their data and applications in production, that's why when we started building Arc-enabled data services about 3 or 4 years back, security was a top priority for us, Thomas.
Yeah, absolutely. I love it. And so Azure Arc obviously brings a lot of these cloud capabilities we have in Azure to on-premises and multi-cloud environments and really helps customers to run their applications in similar fashion as they would do in Azure on-premises or even, as I said, other cloud providers. So when we talk about hybrid and on-premises, many of our users are familiar to use SQL Server. So how does Azure Arc SQL Managed Instance compare to that and deliver a secure platform?
Yeah, absolutely. Not only is our SQL Server engine secure and the most secure database that's available to enterprises and customers, but we are also taking that Azure security and bringing that down and combining it for your hybrid platform. So with industry-leading multi-layered security capabilities, your data is protected both at the powerful database engine level, as well as in the cloud by using the capabilities that we use in Azure Security Center and those that we use to run your database in the Azure cloud. So it starts by design principles that we have perfected over many years of developing software platforms and data platforms. And this one is the hybrid data platform, secure by default configuration, features that are using least privileges when possible, this is that your attack vector is reduced, and deployment supporting configuration that allows you granular resource management. And finally, protection of your data assets, both in rest as well as in motion. This incorporates the security features that are included in SQL Managed Instance, since it's the same reliable SQL Server engine that our customers have been used to over the years.
That's fantastic. I love what you just said about like secure by default, right? We are really try to make this as secure as possible. And so you also just mentioned the SQL Server engine. So like customers who are familiar with SQL Server and the security features, do they get the similar or same with Arc-enabled SQL Managed Instance?
Great point. Like I said, because it's the same engine, important security features are available in SQL Managed Instance. As you can see in this table right now, transparent data encryption or TDE, which is known as encryption for data at rest, it encrypts all your SQL Managed Instance data files. Column level encryption and row level security is also available. And dynamic data masking helps prevent unauthorized access to sensitive data. And as for auditing, we have basic and fine-grained auditing to keep tracking and logging events that have been occurred in the database engine. Now, as you probably know, whether you're running SQL Server on Windows or Linux, or you're running in a containerized environment with SQL managed instance, you get that comprehensive set of capabilities that you can help to secure your data assets. So let's look at this other table, which can compare all of those capabilities, not only available to you on SQL Server on Arc-enabled server, but also many of the capabilities that are available on the SQL managed instance through Arc-enabled data services SQL managed instance. Now, there are some things that are missing, Thomas, but they're coming down the pipe, such as Azure AD support. Absolutely, Azure Active Directory is something our customers who are running their services and data in the Azure cloud want, and we're working hard on it. Azure Key Vault integration, so you can store and retrieve your secrets securely, and more security features coming down with Azure Security Center as the releases progress. So there you go. A comprehensive set of security features are available to our customers through Arc.
That's fantastic. And again, you mentioned that there's more to come. So what are some of the additional capabilities customers actually get when they actually run Azure Arc enabled SQL managed instance?
This is something that's available right now to customers because, as you know, Arc enabled SQL managed instance uses the same SQL MI that runs in Azure, which is running in a Linux container in Azure that is hosted in a CNCF compliant Kubernetes. And we, of course, work with some of the top enterprise grade third-party Kubernetes provider, but it also works on AKS HCI. And it uses some of the benefits of the underlying Kubernetes layer to provide you security features like role-based access control. Now, the thing that is interesting here is that you have two modes for Arc-enabled data services. One is a direct connectivity mode, where the SQL managed instance and the Kubernetes cluster is connected to Azure so that you can take benefits of all the Azure-based security features for your on-premises or third-party cloud hosted database instances, or indirectly connected mode where your cluster and the data SQL managed instance running inside of it is not directly connected to Azure. The key important difference is we use in the directly connected mode Azure role-based access control to assign role permissions in Azure Active Directory or Active Directory to control authorization checks on Arc-enabled Kubernetes clusters. The API server of the cluster is set to use a webhook token to authenticate and authorize all the requests that you're doing on the resources on that cluster. Now, in indirectly connected mode, we align Kubernetes role-based access control features to deploy your Arc-enabled SQL managed instance. The Kubernetes authorization is handled by cluster roles, cluster role bindings, and role bindings, if you're familiar with those Kubernetes concepts. In this case, the authentication requests now that you will do can go through whether you use Azure Data Studio or AZ-CLI, or you're using native Kubernetes kubectl commands, goes through the Kubernetes API layer. The API server then validates the request for the API objects and such as pods, stateful sets, and in between Arc-enabled SQL managed instance uses Kubernetes native dynamic admission controller pattern. So it uses admission webhooks as an extra security control mechanism. So not only do you get the security that's available in the engine with the integration of Active Directory for identity, but we also use the native Kubernetes security control aspects to give you an even more secure environment.
That's great. I mean, I love that we use these concepts and bring those all together to add this initial benefit to it. So earlier you mentioned to me that obviously Azure Arc enabled SQL MI is secure by default. Now, to not just make that statement, but also tell us a little bit about how this platform is architected to be secure by default. Can you help me with that?
Yeah. Absolutely. So it's important for any kind of security design, and we've done this for many years, right from the days of the Windows operating system. secure by default is one of the key principles of our design, so that the least privilege calls are made while running containers as non-root. So when we designed the Arc platform, we followed this principle of least privilege. Only do those actions that require high privilege in high administrator mode, but do most of the other ones with the least privilege. So we support running the containers in which your data services are running as non-root. As a result, even if there is a chance of running some malicious code by mistake, it is protecting your overall data assets from damage as the code runs without the permissions to access and compromise the container host, which runs on the Kubernetes node. Now, our Azure Arc platform is also designed so that any of the actions that the data controller takes, which is the Azure Arc enabled data controller, requires the least privileges. And this was really important for many of our enterprise customers to pass their high security criteria, which we did, to reduce the attack vector. All the data that you're storing inside your SQL managed instances and databases running in there is all protected while at rest as well as in motion, because the security can be enabled at all the endpoints via HTTPS, TLS, SSL. So it's encrypted in motion. And last but not the least, you can use system managed certificates. You can use your own custom managed ones too, but system managed certificates make it even more secure. So from several aspects, we have built security into the design of the platform.
Love it, love it. Again, I think that is very critical to all of the customers out there, especially in these days and these times we are in. So certificate rotation obviously is a very important part of that, right? It's something a lot of times it gets forgotten, and so I love how it is integrated here. Can you tell me a little bit how it actually compares to the traditional SQL Server?
Yeah, so many of our enterprise deployments that use SQL Server today use transport layer security or TLS certificates. In order to keep the environment secure, it is advised that you rotate these certificates on a regular basis, and certificate rotation is very important. To obtain your certificate, you can use Certificate Authority or use a tool like OpenSSL to auto-sign these certificates. When it comes to the certificate rotation on Arc-enabled data services or SQL managed instance, this can be done through either Azure CLI or using kubectl or any of the Kubernetes tools that are available there in open source, which is the native way that many of our Kubernetes customers like to have. But kubectl is way easier and integrated with your DevOps pipeline, like one of our manufacturing customers, to automate that entire rotation process. Now, an important thing to remember here, Thomas, is that this is certificate rotation we do only for the SQL managed instance. So if you have applications and other assets running, this does not apply or interfere with that certificate rotation.
Okay.
So that's how we implement it in SQL managed instance.
Yeah, no, that makes sense. And again, that's definitely a great help in these scenarios. Another question I get a lot is obviously if I run Arc-enabled SQL managed instances, how is the data store in the databases protected? Like, how is the data protected?
Yeah, great question. Data is an important asset for all our customers, especially when they're running mission critical applications, and data leakage can result in huge loss or huge implications for our customers' business. So from day one, we have been creating features in the SQL engine to protect that data. It's important to remember that when you're storing the data in SQL managed instance in Arc, this is not leaving, the data that you're storing is not leaving the cluster and going anywhere else. So any kind of protection that you're applying locally does apply to your data. And Arc-enabled SQL managed instance uses transparent data encryption, or TDS for short, as you probably know, to encrypt that data that is transmitted across the network between client applications, and then Transparent data encryption, TDE, encrypts the SQL server just like it encrypts Azure SQL database and Azure Synapse. It's the same TDE. This encryption is known as encrypting data at rest. So one solution is to encrypt sensitive data in the database and use certificates to protect the keys that encrypt that data. So the solution prevents anyone without the keys from using that data. But you must plan this kind of protection in advance so that your data is well secure. So you need some security practices. And the process used to enable TD is the same set of steps that you've been used to over the years if you've been using SQL Server. TD does real-time IO encryption and decryption of the data and the log files. The encryption uses database encryption key or DEK. The database boot record stores the key for availability during recovery. The DEK or DEK is a symmetric key. It's secured by the certificate that the server's master database stores, or by an asymmetric key that an EKM module projects. This data that you're stored in SQL managed instance can be protected, Thomas.
That's good. That's good. And I think that helps a lot for people to understand how that works and make sure that they can show that to their security teams and make sure they understand it. So speaking of security, obviously we're speaking the whole time of security. No cloud security really is complete without talking about identity and authentication. So what are my authentication options when it comes to Azure Arc enabled SQL MI?
Great point. Identity and access is an important aspect of any application as well as data. No cloud solution would be complete without it. When it comes to authentication, Azure Arc enabled SQL managed instance supports basic SQL Server auth, which everybody knows about over the years, and Active Directory authentication, the same as SQL Server today.
Oh, that's fantastic again, because Active Directory authentication is obviously crucial to all of our traditional and existing SQL Server customers because they're using it today for all their SQL Server needs. So how is that integrated or implemented in Arc-enabled SQL MI?
Yeah, I'll talk a little bit about this right now, and then we'll also see how it works later on in a demo. Arc-enabled SQL MI can be configured to use Active Directory identity, your local deployment of Active Directory used in your organization, by connecting the data service to the existing domain that you want it to be connected to, or authentication domain. The first thing user needs to understand is that the SQL managed instance runs in Linux. And so many of the Linux customers are familiar with this, but we use key tab files. Because Arc-enabled SQL managed instance runs in these Linux containers, we all have to use key tab files to automatically log into Active Directory on startup of that service. The key tab file is a cryptographic file containing service principal names and host names. We need an AD service account to register the service principal names under that account. This AD account or Active Directory account is used by Arc-enabled SQL managed instance to impersonate its identity when talking to the AD domain controller. Then we can use tools such as ADUtil, KUtil in Linux, whatever tools you're familiar with, or KTPass in Windows to generate this key tab information based on the provided AD account SPNs and the DNS host information.
Oh, that's fantastic. So when it comes to key tab, can you tell me the difference when it comes to customer managed and system managed key tab and how we do deal with that?
Now that we know about the key tab file, there can be two ways to do it. Either customers or you bring in your own key tab files, or we as a system provision those and manage those in Arc-enabled data services. With customer managed key tab files, it's up to the user to provide this, Thomas, to a pre-created Active Directory account and registered SPNs under that AD account, and then generate that key tab file using Active Directory management tools such as ADUtil. In a system management mode, user only needs to provide to Arc the organizational unit or OU and the domain service AD account, which has sufficient permissions on that OU level in the Active Directory. The system will then generate under the covers a domain service AD account for the Arc-enabled SQL managed instance. This is all automatic, taking out the complexity out of that entire process. So we give you options whether you want to do it manually or the system manages for you. The system configures the SPNs automatically on that account. The key tab file is generated and it's delivered to the Arc-enabled SQL managed instance. So the instance can use it every time it needs to talk to the LDAP server. Then we provide the manual key tab rotation experience that you get from the custom manage also for this when it comes to customers to manage that key tab. And Arc-enabled SQL managed instance auto manages the key tab rotation for system managed key tab files. So overall, you have choices, and we'll see how this flow works and then look at the demo after that.
Oh, that sounds great. And one thing I have, like both, it sounds like both of them have advantages. And so, how does a customer decide if they're using customer managed or system managed key tabs? And can you tell me, like, how do they figure out what is right for them?
Yeah, very simple. If the customer needs more control, more flexibility, is required, then certificate management is recommended to stick with customer manage because you want to control what key tab files are being used. Whereas if you want a highly automated process, you don't want to handle these key tabs and you want them to be automatically managed, you can use system manage. It's as easy as that. What we see is that smaller customers typically tend to have the user controlled customer managed key tab files, but as you go on a large scale, probably the system manage makes more and more sense.
So, can you show us that a little bit in action? You promised me a demo.
Yeah, so let me talk about how this works. Let's look at the system managed scenario just to make it easier. The custom managed takes a lot more steps because it gives you a lot more control, but then you have to use all these tools. So in a system managed scenario, at first, the Active Directory administrator creates a dedicated service account or a DSA, a SQL managed instance OU specifically for the SQL managed instance, and grants permissions for the OU to the DSA. The next step, you onboard the AKS or Kubernetes cluster to Azure Arc. Okay, so you just connect it using capabilities in the Arc platform to Azure. And in a custom location of your choice on that Kubernetes cluster, you can add data services extensions onto it, which means now you have enabled that cluster to run data services. The first thing you do to deploy data services is deploy data controller. The extra step that you want to do if you're doing AD is configure an AD connector and provision it using the system managed key tab file. The connector is a Kubernetes custom resource that implements the DNS proxy service to talk to the AD domain services under the covers. And then you deploy the SQL management instance, and you're on your way to deploying SQL databases. Now let's take an example of how the authentication works next. So let me get into the next stage of the conversation. You've deployed a cluster, you've Arc enabled it, you have enabled data services on it, and you are ready to deploy a SQL managed instance service. Let's take a SQL client or Azure Data Studio being one of the clients. What the admin does with Azure Data Studio is sends the authentication request through an integrated AD experience. Active Directory service then receives a Kerberos ticket. Now ADS uses that Kerberos ticket to authenticate against the DB instance. This is all done under the covers and very automated and easy to use. And if you've been using Active Directory for many years, it's just going to work for many of your applications that have been used for that. So let's get into the demo next. In this demo,
We'll see how the Active Directory authentication can be used with Azure Arc enabled SQL managed instance using an existing Active Directory domain. We're going to see how an administrator at Contoso, a customer of Azure Arc enabled SQL MI, sets up an Active Directory authentication for SQL MI in 3 easy steps. Step 1, they deploy the data controller. Step 2, they deploy the customer managed or system managed key tab AD connector. We'll just show the easier system managed as that's the recommended approach, and it cuts down a lot of the manual steps. But we can see that some customers may want more control over the key tab file, and hence using a customer managed AD controller setup. And finally, we'll deploy a SQL managed instance using that AD connector. In order to enable Active Directory authentication for a SQL managed instance, the instance must be deployed in such a way in that environment that it allows it to communicate with the Active Directory domain. So what are the prerequisites? To be able to create all the required objects in Active Directory automatically, AD connector needs a domain service account. We'll call it a DSA. This DSA is an Active Directory account that has specific permissions to create, manage, and delete user accounts inside the provided organizational unit. So number 1, create an organizational unit for all the Arc-enabled SQL managed instances or use an existing one. Number 2, create or assign an AD domain service account or DSA for the AD connector you're about to create. This account needs the right permissions to read, write, create, delete user objects in AD and reset passwords. You can find steps to do this in the online documentation, which can be executed by any domain administrator. Typically, an OU with a DSA or a domain service account is linked to an AD connector. This gives a separation of scopes each AD connector is touching in that domain. The way this works is an AD connector connects to SQL MI to an Active Directory domain controller to do the authentication. AD connector deploys a DNS proxy service that proxies the DNS requests coming from the SQL managed instance to either of the 2 upstream DNS services, Active Directory DNS server or a Kubernetes DNS server. It also deploys the security support service that creates the communication channel to AD domain. Now let's first assume that this is a Contoso resource group used in Contoso. It has an on-premises Contoso Kubernetes cluster, AKS, and a custom location on top of it where a Contoso DC data controller is deployed. Now you can see that there is Active Directory domain controller or Active Directory AD connector already connected to it. But let's see how to create a new AD connector. Let's deploy a new AD connector in a system managed, which means an automatic way. Now let's see what inputs you have to give. Realm is the AD domain that this instance of the AD connector will be associated with. The name server IP address is a list of Active Directory DNS server IP addresses. The DNS proxy service will forward DNS queries in the provided domain name to these servers. We will use a simple local one for the purposes, but in a real-world environment, the AD administrator should know these values. And we'll use the default OU name. We'll create a domain service account and give it a password. Now the remaining entries are optional. There's the primary domain controller host name, which is the FQDN of the primary domain controller. There's the secondary domain controller FQDN, the NetBIOS name of the AD domain controller, and DNS replicas is the replica count for the DNS proxy service replicas field in the AD connector spec. It's used for the DNS proxy replica set we deploy in the AD connector. It only determines how many pods of the DNS proxy to deploy. Now, check this box if you prefer a Kubernetes DNS server response over the ADS DNS server response for the IP address lookups. Then you add a new connector. You can also do this by applying the YAML to kubectl commands. We've already created a Contoso ADC. So now let's go to see how the SQL managed instance should be created and connected to the AD controller. So go to Contoso RG and then let's create a SQL managed instance, Azure Arc. It also selects automatically the Contoso resource group. Now let's give it a name. We'll select a custom location, Contoso CL, the service type as load balancer. Now we'll give it a admin and password, which is used to log in for the first time. And then we'll check the enable AD authentication. It automatically selects the AD connector that's part of the custom location. Let's give an account name for admin that is used for first login, a DNS name, and we'll use the DNS port service, which is the default. Now you can review and create this new SQL managed instance. In order to save time, we've already set up the SQL managed instance here. So let's cancel out of this and inspect the SQL managed instance. Here's the external endpoint that you can use for connecting from any client.
That was great. Now we have the setup of the AD authentication connector with the data controller. So how does now client authentication run in this case with SQL managed instance?
Yeah, the administrator came in, Thomas, and set up the entire infrastructure. So now either the developer or the application owner can start provisioning SQL managed instances on top of it. So now let's get into the demo of how the SQL authentication works and how easy it is for you to use your applications that are AD enabled to use in this environment. So let's go into that demo next.
In this demo, we'll show how AD authentication works with the SQL MI instance created. We'll use Azure Data Studio as one of the clients, and we'll connect a connection to the Microsoft SQL Server using the connection string from the SQL MI endpoint that we got from the portal or the Azure console. First, we'll use SQL login and give it the username and password, which was the SQL login that we created during creation of the SQL managed instance. Now we can go to the master database and let's run the command to create a new login that we'll use for AD authentication. So we'll create a new login, arcadmin. Once you run this, you can verify that the login has been created. Now let's create a new connection. This time, we'll use the same server connection string and we'll use Windows Auth. Now it's logged in with the authenticated user. So we can now run the command to find out what is the name of the authenticated user. And you can see that we have logged in with the authenticated user. That proves that Windows Auth is working.
Thank you, Dhananjay. That was a great demo. I also understand that there are, by the way, two different tiers when it comes to SQL managed instances, the general purpose tier and the new business critical tier. How do the security features compare in those two tiers?
Oh, great catch there, Thomas. They're the same. At Microsoft, security is our topmost assurance to our customers. So we enable the same high-level degree of support, both to the users of general purpose tier who want to run applications that may not be mission critical, but also to the business critical tier.
It's fantastic. Again, I love that we are not saving on security at all. We are really all in on that. And I also love to see that we're obviously very close when it comes to Azure Arc enabled SQL managed instances and traditional SQL servers. And what I also like is that we can get even more, especially when it comes to the connection mode. And there's absolutely more to come, especially with the integration of, for example, Microsoft Defender and much more. So thank you very much for showing us what is possible with Azure Arc today. So if people now want to learn more, Dhananjay, where do they go?
Yeah. So one is to check out our documentation page. We'll add some links over there. We are also having learn content being created. Your channel is a great channel to learn more about it. We have jump starts being created and Arc boxes, which you can use. And first and foremost, get started, download Arc and start using the trial version of Arc All Up and Arc enabled data services.
Thank you very much, Dhananjay, aka DJ Data. It was great to have you today. And thank you to everyone watching. If you want to learn more about our hybrid and multi-cloud architectures, check out the Cloud Adoption Framework and the Azure Architecture Center.